Okie doke. That's from Michael Griffin. Example 7, last example from lesson 4.7. Here you are not using numbers, which is kind of a bummer, but we are still going to be drawing triangles. We're going to write each of the following as algebraic expressions in x. So we have to think of our arctangent of x, which that's going to be in the first quadrant because x is positive. So we need to draw a triangle in quadrant 1. And when we do that, we have to figure out the tangent. Well, the tangent is your opposite over your adjacent. Well, what's our adjacent here? Oh, hey, if you have an x over nothing, actually you have an x over 1. So your adjacent side is going to be a 1. Your opposite side is going to be x. So in order to figure out what your hypotenuse is, you're going to have to do your Pythagorean theorem. You're going to say 1 squared plus x squared equals your hypotenuse squared, which this is no different than what we've done before, except we're just not using numbers. You're using expressions instead. So if we take the square root of both sides, h ends up equaling the square root of 1 plus x squared. No biggie. It's just an algebraic expression. So we're still going to find our, in this case, our secant of theta. So our secant of theta, oops, wrong color. Secant of theta is your inverse of your cosine. So if we're trying to find the secant of theta, your cosine, remember your cosine is your adjacent over your hypotenuse. So that means that our secant is going to be the hypotenuse over our adjacent side. So your hypotenuse is radical 1 plus x squared. Your adjacent side is just 1. So we would just say radical 1 plus x squared. That is going to be our solution. So we still drew a triangle. We used what was on the inside to help us draw a triangle. And then after that we had to use the function on the outside to find our answer. Same thing here for b. Since the arc cosine of 2x, this is positive. It's also over 1. We need to draw a triangle in quadrant 1 again. And, whoa, that was a nice straight line. Hopefully your guys' triangles are better. Doubt it. And so the tangent, or the cosine, that is your adjacent over your hypotenuse. So our hypotenuse is 1 here. Our adjacent side is a 2x. So we need to find out what y is equal to. So once again, Pythagorean theorem, 2x squared plus y squared equals 1 squared. So you get a 4x squared, not a 2x squared, plus y squared equals 1. Subtract 4x squared to both sides and you get y squared equals 1 minus 4x squared. When you find the square root of both sides, do not find the square root of 1 and the square root of 4x squared and say, oh hey, this is just 1 minus 2x. No, no, no. No, 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 no. You cannot simplify it that way. So your y is actually radical 1 minus 4x squared. So we plug that in for y, and now we need to find the tangent. So your tangent of theta of this equation, or of this picture, is your opposite over adjacent, TOA, which is going to give us a radical 1 minus 4x squared all over your adjacent side, which is a 2x. So the big part here about 4.7 is two big parts. You need to know your circle. You need to make sure on the last parts here you are drawing triangles. What's on the inside helps you draw your triangle, is your triangle. And then outside is the function you have to evaluate. So, like this says here in the bottom, I'm only responsible for what I say, not what you understand. If you don't understand something, then it's probably Brendan's fault.
Yeah, boy!
Oh, hey, little Mike's back. Little Mike. Only.
Just drinking some dew.
Just having some dew. Alright, well, I'm going to go finish off my Mountain Dew while I go do my homework. Haha! Psych, I don't have homework. Later, folks.